Thank you, Benny, for the invitation to speak today. I am Michael Shea. I'm the managing director of an organization called Wider Team that is based out of London, though I'm currently living in Vienna, Austria. My background is I'll get to that. What we're going to be talking with today is advances of DIDs and verifiable credentials in IoT. The content of the presentation does have a very strong mobility theme, but I've also blended in some other elements of what's been going on over the past 6-12 months, specifically in the IoT area. The outline for what I will be talking is today a bit of an introduction of myself, some of the research that's happening around SSI and IoT, covering some of the pilots and POCs that are currently, that have been shared and that are underway. Following up with some just quick projects, and then a review and wrap up. And I will work on moving quickly, but slowly to aid the translation, but also to try and stay within the time slot. As I mentioned, I'm Michael Shea. I'm the managing director of Wider Team. I'm also the chair of the Sovereign Foundation SSI and IoT Working Group, and a co-chair for a trust and identity subgroup for IEEE standard P2933 on clinical IoT. My background is back when I started my career, my career was I was heavily involved in embedded systems, real-time automation, then moved over into enterprise and the business side. So I bring both a combination of a business perspective with a strong understanding of the technical, but probably the very fine point of the technology pieces are, I tend to defer to other folks. Wider Team is a new organization, about a year old. It is a collective of individuals who are strong in their strategy and technology consulting, particularly specializing in DIDs and credentials, the value of DIDs and credentials in an IoT, in a more of a thing context, digital twin context, than focusing specifically around SSI and individuals. So to start, SSI, some IoT research that's happened that has caught my attention over the last 12-18 months. There was a project that wrapped up around this time last year. It was an EU project called the SOAI project. They had SSI was a key part of that project. And one of the papers published that I will share here with you was around the use of ephemeral identity for privacy in maintaining the privacy of an electric car owner. To make sure from a terminology, an ephemeral identity is a transitory identity. In the world that we are currently living in, we're always on and always connected, and it's becoming harder and harder, obviously, to have the privacy around the transactions and how we deal with and interact every day. An ephemeral identity is time limited. It could be very short. It could be just for the transaction, or it could have some sort of a time bound on it. So it is worth reminding that while some will raise up questions about the need for ephemeral identity, how societies all over the world functioned, this is how we have dealt with and worked in most of our engagements and interactions over time. We do not supply identity when we go into the gas station right now. Excuse me, to fill a car. You go to the pump, you may pump the gas directly, or you may put a credit card in and put the nozzle in your tank, fill up your car, and off you go. There is no need for the owner of the gas station to know who you are. The temptation as we become a more connected world, and as you have an electric car being plugged into a charge point, that not only the identity of the car, but the identity of the owner of the car in this data aggregation and data collection mode is very tempting, or has been within the world, the technology world as we all know it. So within this particular research, they looked at three modes of, they were looking at three questions they were looking to answer. One was a fixed DID, the second was a single-use DID, and the third was the use of privacy ring signatures to encrypt the transaction to provide the privacy that way. They ran their study across Norway, which has a very high penetration of electric vehicles. And the net result was, in looking at the time that required to either encrypt from a ring signature perspective and the privacy from an ephemeral DID, that there was very little loss in privacy by using an ephemeral DID versus having to use ring signature encryption across all the transactions to get privacy. So in this diagram here, each of the components, the DSO, the ER, the vehicle user, the charging station owner, all of these points have identity and had a DID within the research. But it was the electric vehicle user identity that then was being modified from a fixed DID to a transitory or ephemeral DID, and so that the identity at the charging station could not be determined. So the result was that the recommendation of going towards an ephemeral DID or transitory DID that was validated in the research as there was not a significant loss of privacy, and it's a much more efficient mode of acquiring that. The second research that was done was around constrained devices. In the IoT world, there's the constant question about can a device do the cryptography or cryptographic operations that are necessary in order to do something like DIDs and verifiable credentials. They looked at, this is also part of the SOAI project as well. They looked at a range of MCUs, microcontroller units or CPUs, and they were looking at for 4 constraints around devices. One is the processing power to be able to actually do the cryptographic operations. The second is entropy, having enough variation or randomness to allow a key to be calculated that can't be easily or quickly hacked. The third is battery power. Many IoT devices operate via battery. And so having something that draws a lot of power shortens the life of the device and then becomes very problematic. The final element is secure key storage. This really then becomes a hardware requirement for the design of the device that enables secure key storage. So whether that's through a secure element or a trusted execution environment to allow that to happen. The outcome of this research was that even on an 8-bit microcontroller, they were able to do the ECC cryptographic operations. They're able to perform about 1 to 2 cryptographic operations a second. So the challenge of saying that it's not possible to do this on an 8-bit microcontroller was proven to be not correct. They also looked at 32-bit CPUs, microcontrollers, and in the 32-bit environment, we're able to do about 13 ECC operations a second. This is really sufficient for most use of what would be used in this class of device. What was interesting is that the challenge really is maybe more, let's say, a product management or business costing question. These CPUs or these components with the secure element are slightly more expensive than a device without the appropriate security technology. And as a result, they don't get selected. I think what is happening in the IoT space is that the world and the regulatory legal frameworks are becoming much more aware and sensitive to the large problems that are starting to appear around security and the exploding world of IoT, and how one insecure device in a network environment can create a hole through which a myriad of attacks can originate. So my sense is that the solution, part of the solution here, is a combination of technology, which this research has proven such that it is possible, and regulatory, the stick incentive of pushing people to actually start making the secure elements as part of the requirements for operation. The third area that was very interesting is some very interesting research done by a doctoral student down in Brazil, who has been an active member of IIW or participant, I'd say, of IIW over the last few years. He has looked at particularly how to communicate over constrained networks. all the conversations that have gone on today had an underlying assumption that communication was running over an HTTP type network connection, where effectively you're not really constrained by there's not really any size constraints practically today. When you get into the world of IoT, and particularly something like a LoRa communication protocol that's meant for low energy and long range, the world changes quite drastically. LoRa packet size is limited to 240 bytes. So in this research, they were looking at IoT swarms, swarms of devices that could be in an office, and the ability to communicate between them using DIDs to try and build also a zero trust framework within the devices. I've included a couple of a few of the charts from the work here on the slide, and you can see really the different sizes of the DDO is the DID document. Even the standard JSON DID document is between 500 bytes and over a K. This becomes a real problem when you then get into a constrained network like a LoRa network. The researcher here, the doctoral student, created what he called a DIoT com to allow the exchange of and he fundamentally redesigned the DID document and how the modes of the overhead into the payload and packet size. The output of his work was such that he was able to get the binary DID document down to 128 bytes in size. So he's using what he called a CBOR DI for serialization. He has also dropped out. He's made some choices, some design choices around the structure of the DID document, such that it was designed to work with the environment it was operating in. I think it's fair to say, if you look at the DID document as it is defined in the current W3C proposed standard, it's designed to work. That is designed to work in a mobile device, server cloud-based system where there's really very little constraints applied to it. When we come to these small devices, it's legitimate, I believe, to consider changing that or taking a different viewpoint, as this researcher has done. So he's done away with he's used an array instead of key value mapping. He's encoded the DID and key values as raw bytes. And he has ended up using, like I said, a CBOR. He called it CBOR DI. CBOR for DID documents for IoT. The net result has helped him bring the overall payload size, like I said, down to 128 bytes. This research is ongoing. In this work, he did not look at the verifiable credential, but he said there's a lot more challenges around actually trying to do the similar thing on a verifiable credential side, but he has set this up such that they're able to actually communicate over LoRa using what he's called DIoT com. So it's some interesting stuff that's going there. Next, we'll look at some pilots and POCs. Okay. Next, looking at some POCs and some pilots that are underway. This deep parking multimodal mobility POC. Actually, I just came across this very recently. This was done by a company called Mobix in Munich last fall at the world's largest automobile trade show, auto trade show, the IIA. What the pilot was, or POC was, is a combination of using SSI, using DIDs and credentials in the getting a car from the summit area here where the main trade show was happening, finding a parking place that was in downtown Munich. So the driver of the car would get in, would identify himself with a credential in the car. Then it would start the journey into Munich, and then find a parking place in there's three or so different parking garages participating in this POC. What SSI was used for, or underlying, there is a autonomous economic agent that is doing the searching across the available parking spots. There is identity of the vehicle. When the person selects, or the car, the economic agent selects the parking spot, it then provides the directioning to where that parking spot is, and also identifies the car as it comes up to the gate in the parking garage. So let me just back up 1 second. Let me stop. In the system, they used a virtual autonomous agents to register the available parking spaces, and a micro-mobility use case around the user's location. The system was powered by SSI based on the Aries framework Go, and included the Mobix wallet, which is an edge agent, and it handles the communication between the car and the parking hubs. Parking hubs provide the parking info, and these were also cloud agents that issued reservation credentials. All the electric vehicles, and there was 3 or 4 vehicles in this pilot, were equipped with Raspberry Pis and mobile data to enable an SSI cloud agent. The gate controller that gives again another Raspberry Pi unit that performed the used SSI, so the credential was used to do the reservation verification. And underlying all of this was a system by Fetch.ai that had the economic agent, autonomous economic agent, that managed all the communication between the agents and the parking space. So this is just a slide around the technology underneath. So it's, SSI was used to connect the agents with each other and communicated via DIDCOM. In this case, it's DIDCOM v1. It was used for the credential exchange and presentation. This was based on the ID Union SSI chain, so which is a Hyperledger Indy, and excuse me, the user, just a quick process flow here of the user establishes a connection with the car. The car then connects with the parking hub, books a parking space, pays the fees, and requests the parking credential. The credentials stored in the car's wallet, not in the individual, because it's the car that needs the space. And as it approaches the parking garage, it connects with the gate control unit and presents the credential. The gate control unit then opens the gate after the verification, and the person parks the car. Related to this, and this sort of or matches a comment Wayne just had in his presentation. Moby is an organization, it's a global association primarily in the auto and mobility industries. Members are the different auto manufacturers and parts suppliers, OEMs, in the auto industry. They have been working on this to creating an ecosystem around vehicles and mobility. The purpose of Moby is to create standards, reference architectures, and governance models for the mobility industry for connected vehicles. The first two use cases that they have worked on is around vehicle registration, and that's essentially the birth process, if you will, of a car or a mobility device. The vehicle registration is referred to as a VID or a VID, which is a combination of the VIN, which many people will be familiar with as the vehicle identification number, a long alphanumeric string, and a DID that they are then anchoring. So they're creating using DIDs to create that digital vehicle ID today. The vehicle ID, the VID, is used then to unlock a range of new services. These are covered here: the asset visibility, data provenance, anchors for additional use cases, and as we just talked about, autonomous economic agents, connecting to autonomous economic agents. Asset visibility is then should be regarded as providing the traceability and visibility of the life of the vehicle. I think anyone who has purchased, particularly a pre-enjoyed or secondhand car, all knows the uncertainty of what's happened to this vehicle over its lifetime. Has it had an accident? Has it had some major problem? Has it had all of the appropriate recalls or safety items fixed and addressed within the car? The objective here is to make that completely transparent and traceable over the life of the car. The data provenance, then the VID is used to secure data exchanges at the edge. So that again, this is something that within the IoT community, having that traceability and data provenance of knowing where the data has sourced from, where it has come from, is extremely important and valuable in the economic process. It's also looking at an anchor for additional use cases. And we touched on the economic, the autonomous economic agents from the transaction perspective of what's happening in the Mobix use cases. As we would expect, there is similarity in the approach of the data of the vehicle stays with the vehicle. So the data is the data from the vid data is stored on the vehicle, and it's under the control of the owner of the vehicle. Also similar conversations of the agents that are involved here, whether they're in the cloud and at the edge, and it's a combination of both. And as you go through, if you're not familiar with some of the reference architectures from Moby, you are starting to see, or you will see as you go through them, that the DIDs, verifiable credentials, verifiable presentations, are completely through the reference architecture and work that has been done. So while many in this community are very familiar with the conversations that have existed around the person identity and how that works, the very similar conversations are happening within the device and the IoT world as well, to make sure that the governance models and things are set there as well. So this is the last section here around some projects that are currently underway. The EU has been a strong supporter of SSI. I think, again, many people from the presenters will be aware and have probably taken advantage of funding from the EU around the whole next generation internet NGI, ASIF, ID Union, EBSI, all of these EU-funded projects and efforts are around person and organizational identity, education, things of that nature. There are also projects or funding efforts around IoT. I mentioned earlier in the presentation the SOAI project. That was a H2020 project. There is currently a large effort called the Next Generation IoT, of which SSI is integrated into several projects there, one in particular called IoT Engine, NGIN. That's at the full European Union level. There is then also specifically in Germany a project called ID Ideal that is sponsored by the Federal Ministry of Economic Affairs. And it is looking at how digital identity is integrated into 6 areas of life. They classify these as the city, the town, mobility, trade, industry 4.0, energy, and campus. Well, that's actually 7, so it's a combination there. In the IoT context, the industry 4.0 and mobility are the places where work is going on, including DIDs and SSI. The use case that they're specifically looking at is around the hiring of industrial equipment, the rental processes. This is a project called, or an SSI participant called Evan Network that is working as part of this project. And they are using it for the identity of forklifts and the rental of forklifts in a commercial setting. So the identity of the operator, as well as the machine and their qualification to be able to use the machine is part where they're using DIDs and credentials in this context. They're also looking at the context of this project of bringing in digital twins and the leverage of credentials, data provenance in the digital twin context as well. Another standardization effort that is underway is a decentralized IAM for IoT. This is a IEEE, it's an IEEE standardization process, P2958. It is a, I'll get the term right, an organization IEEE project versus an individual. Really the detail there is that you must be an IEEE organizational member in order to participate. This is chaired by an individual, Jinjin Fan, who is the head of cryptography for IoTeX and is an active supporter. And IoTeX is another project particularly aimed at what's being termed as machine-fi, so bringing DeFi to IoT devices, the machine-fi, but using DIDs and credentials as an integral part of IoT lifecycle, device lifecycle. This effort was launched in the second half of last year. It has participation of large device vendors like Bosch, like Huawei. So this is just in the starting phase of this project. So if any of the listeners or the people participating are of that interest, please shoot me a note afterwards, and I'm happy to introduce you or connect you with Jinjin if this makes sense for what you're looking to do. Okay. Finally, just a plug here a little bit. As I mentioned at the beginning, the Sovereign Foundation has had a SSI and IoT working group for about 18 months now. The working group is welcomes all participants from all different projects. It's not specific to one particular, the sovereign ecosystem. The challenge and the opportunity around SSI and IoT is too big and too broad. We're currently working on a couple of work items. First is a top-down approach of getting the Aries agent onto a Raspberry Pi. This is the Python agent, with the objective here of making it supported and supportable to allow people to start to experiment in the Raspberry Pi using DIDs and credentials in an embedded environment. That's the first area. Then we're also looking at a bottom-up approach with DIDCOM and building up. We are also putting together a few white papers around DIDs and VCs and digital twins. There's some of the conversation has been around whether or not an agent is effectively the container of a digital twin or a digital twin. But looking at that to see where we can create some thought leadership within the ecosystem, within the environment, around the value that DIDs and credentials bring into the IoT world. As I said, this is an open working group. We try and keep it to areas that are completely open and shareable and not involving IPR protected information at this point. So just to sort of review where things are, the amount of work that's going on with DIDs and credentials in IoT has really, continues to grow. 24 months, 30 months ago, there was not a lot of certainly not a lot of public information. There was just the start of recognition of the value or potential value of DIDs and credentials in the thing space. That's changed quite dramatically. If you do literature searches, there's now an awful lot of research that's going on, whether it's research like the projects from the EU or Mobix or the work that Moby has done or doing. There are doctoral candidates that are focusing on this area within the IoT and the thing space. So there is a lot of work that is going on. There is the private sector is very active in this. It's a little more challenging to get some information from the private sector side, since some of this is not shared widely and openly. But you get the examples like what Mobix has done to get an idea of all the pieces that are involved there. The partners that were involved with Mobix were Bosch, Ocean Protocol, Fetch AI, and Mobix, so that you're starting to see how that's coming across. People are changing their viewpoints or their perspectives to looking at ecosystems versus their walled gardens of their own product space. Industry is starting to see the real economic value of DIDs and credentials, and I think that this is maybe the contrary voice or the different voice here of within the IoT sector. The progress might appear to be slower or more methodical, because once released, there can be very severe negative consequences if a device does not work appropriately, particularly when you get into things like mobility. So these organizations move in a much more controlled and methodical manner as compared to some of the other sectors in technology. But they do see that the value has been recognized, and it's like a steadily building wave. And I think one of the points is we may actually see an acceleration in the IoT and the industrial side, because I think businesses are seeing where the economic value lies, and they don't have to convince an individual to get a wallet or do all of these other things, because they're not a direct consumer related item. The convincing or the business justification has to be done at a business value level, which I believe is easier to establish. It may be more difficult to get it fully implemented, but you go from nothing to a lot very, very quickly once it's set up. Finally, I will do a little bit of a plug here. I run an event called the Vienna Digital Identity Meetup. It's in its 4th year. There's about 500 plus members of this meetup. It's primarily focused around SSI, but occasional conversations that are just purely digital identity and other technology providers. A lot of the presentations or topics that I've talked about here today I've had speakers from these organizations present. Time-wise is probably not most conducive to the Asian market. These events are usually 7:30 p.m. Central European time. But if there are members of this community, particularly in the Asian market, that are interested in these topics and in these presentations, I am certainly willing to adjust some of the times to make it fit and to allow your participation in these events. Like I said, a little more than half of them I have actually had them recorded before I actually started recording them, and are up on a Vimeo channel with the link here. You're certainly welcome to participate or to view them, and join the meetup and become aware of what's going on. So with that,